Welcome. This question says, at a point of interest, the sound from a whisper has an intensity of 3 times 10 to the minus 9 watts per square meter. And then I give you this information, remembering that the base intensity is 1 times 10 to the minus 12 watts per square meter. What is the sound intensity in decibels? So I'm imagining there's a person and they're kind of like listening with their ear and the sounds coming in, and if you were to put a meter there, you'd find that the intensity of that sound would be 3 times 10 to the minus 9 watts per meter squared. And the problem with this intensity measurement is that it really takes no account of the biology of the system. What we find is that a factor of 10 change for low intensity sounds is kind of as significant as a factor of 10 change for high intensity sounds. And unfortunately, when you do a linear scale, if you have 0 and then you have, say, 1000, then we have 100 is way down there and 10 is basically down here. And what you find is that a factor of 10 change down here is tiny, whereas a factor of 10 change down here occupies all your interest. But for instance, hearing, the factor of 10 change at the bottom is kind of as interesting as a factor of 10 change at the top. So what we do is we get it with a linear scale, if I can do this right. And what we say is, oh look, so where's my pen gone? We say, oh look, yeah, this is not 0, this is 1, and this is 10, and this is 100, and this is 1000. And that's much more how your hearing responds. So we need a way of giving numerical values that more closely represent the response of the hearing system rather than this just linear scale. And so Bell actually did an awful lot of work on this, and this is I don't know if it's actually done by him or named after him, but the decibel scale says 10 and then log, not natural log but base 10 log, and then the intensity of sound that you're interested in over, we have the base intensity, and this base intensity is the intensity of sound, which is the smallest intensity that a typical human can hear. And I naught is equal to 1 times 10 to the minus 12 watts per square meter. It's a realistic but somewhat arbitrary measure. Different people have different limits. So we're comparing. The decibel scale is kind of saying, how do these compare? And so we substitute in now. We say decibels is equal to 10 log, and my intensity, of course, is 3 times 10 to the minus 9. And my base intensity is 1 times 10 to the minus 12. So my decibel scale is equal to 10 times log. This is going to be 3 times 10 to the 3. And because, the log to the base 10 basically counts the number of zeros, I know that this is bigger than 3 times 10, which is 30. And because this isn't 9.999, I know it's less than 4 times 10, which would be 40 decibels. So I know this is between 30 decibels and 40 decibels just by looking at it. And if I look at this and get my calculator, what I see is that 10 log 3e to the 3, which is what I'm looking for, is 34.77. So this would be 34.77, and the unit is the decibel, the dB. The hearing system of a human being, a healthy human being, is just an amazing instrument. There's very few. You cannot make microphones that work as well over such a wide range of sound intensities. Speaking of which, we've got thunder outside. We cannot make instruments like that. So this is a biological system that just works phenomenally. And so this is a traditional scale used by audiologists and the like to indicate the sound intensity in a more biologically relevant way than the watt per square meter. So there we have it.